Today we're going to start factoring quadratics. Those are the ones that are second degree polynomials. There are several different methods to factor quadratics. We start off with the GCF, which is the greatest common factor, always. So for example, starting out very basic, if we wanted to factor 3x plus 15, the GCF is 3, and when we divide 3 out of 3x, we get x, and when we divide 3 out of 15, we get 5. And we can check ourselves because if we distribute back in, we get back what we started, okay? So the example 1 is 15x squared plus 45x. The GCF, 15 goes into both of them, and x goes into both of them as well, okay? So when you distribute back in, you'll get 15x squared back plus 45x, okay? Very basic. And another form of factoring that we're going to see results from what we call factoring by grouping, okay? So when we look at example 1b, we've got something that looks like this. I'm not exactly sure, but I'm just kind of going with it, okay? So this would be the result of something that is done, a polynomial, a 4-term polynomial that is factored by grouping, okay? So the GCF here is not just a single number like up at the top. It was just a 3 that we factored out. In the second example, we factored out 15 times x. In this type of a factoring situation, what's common is this whole entire expression. So that is what gets factored out, and what's left is the 2x plus 3, okay? And we will learn factoring by grouping, but this is an exercise in beginning to recognize the greatest common factors are not always just single numbers or a number multiplied by a variable, okay? Now, moving on with our factoring, we've got what we call basic factoring, where the leading coefficient, the number stuck to the x squared, is a 1, okay? So we've got in example 2a, okay, we'll go through these just so you know exactly what's going on, okay? And I'm also going to teach you a sign trick right now, okay? So I'm going to color coordinate, and actually this is not the example I want to start with. I'm going to start with the example 2b first, because that's the best way to explain the rule that I'm going to tell you about the signs, okay? So this is example 2b. Okay, so I am going to color coordinate some here. Okay, now we will call the red sign, this one right here, that is the second sign, because the blue one is the first sign, okay? So if the second sign is positive, if the second sign is a plus, then both factors have the same sign in them, and that sign is whatever the first sign is. In other words, this sign right here, the second sign, is a plus. So because that's true, the sign that goes in each one of these factors is going to be whatever the first sign is, which is a negative, okay? So that's how our sign trick is going to work, to tell us what signs go in the factors, okay? So let's just stick with that rule, and then when the second sign is not a positive, I will give you that set of rules underneath, okay? So the first sign is a positive, the second sign is a positive, so the signs in the factors are both minuses. Now we need two numbers that multiply to be 24, so let's get all the factors of 24. 1 times 24 is 24, 2 times 12, 3 times 8, and 4 times 6. And then if we kept going, we would just be repeating. 6 times 4, 8 times 3. No need to repeat. So once we have all the numbers that multiply to give you 24, we need to find the one combination that when you either add them or subtract them, you're going to get 11, okay? Well, 3 and 8, when they're both negative, add up to be negative 11. So negative 3 times negative 8 is positive 24, and negative 3 minus 8 is negative 11. So those are the factors of x squared minus 11x plus 24. So let's check this by distributing just to make sure that we get back what we started with. Because if you factored this correctly by foiling it out, you'll get back to the x squared minus 11x plus 24. So let's check ourselves. X squared minus 8x minus 3x plus 24. Negative times a negative is a positive. Then we've got our like terms here. So x squared minus 11x plus 24. That's what we started with, so we know that we've factored it correctly. Okay, using the exact same idea, okay, what we're going to do now is example 2a. Okay, so underneath here, we've got x squared minus 4x minus 21. And we're going to look at our second sign again. Now, the second sign there is not a positive. So, if the second sign is a negative, then there is a positive and a negative in the factors. One in each. One in each. Okay, so in other words, this second sign is a negative. Okay, so once we see that that's a negative, we know that there's an x plus and an x minus. That's what it means when it says if the second sign is negative, then there is a plus and a minus in the factors, one in each. So a plus in one, a minus in the other, and no, it doesn't matter where you put the plus and the minus. What does matter is that you put the numbers correctly with the plus and the minus. For example, we need two numbers that multiply to be 21. So all the factors of 21, 1 in 21, 1 times 21, and 3 times 7. That's all we got. We've got no other options to get the multiples of 24. Those are the only numbers that we have that multiply to give you a 21. Now, some combination there of plus and minus is going to give us a negative 4. Well, we know that 7 minus 3 is a positive 4. So instead of a positive 4, we need a negative 4. So that means in order to get that negative 4, the 7 has to be negative and the 3 has to be positive, because 3 minus 7 is negative 4. And positive 3 times negative 7 is negative 21. Okay? So moving forward, we've got now in example 2C, okay? Remember, we always start with looking for a GCF. Always start by looking for a greatest common factor, because we got a lot of stuff going on there. First of all, we have no abilities yet to factor a cubic. As far as we go, we've got the GCF and we've got a second degree. We will be able to factor anything bigger than a second degree with the rational root theorem, but we are not there yet. And that is a third degree polynomial. So we need to look for a GCF. Okay, first of all, 3 goes into all of these numbers. Therefore, negative 3 will go into all of these numbers as well. Okay, and we've got a single x. You can't take out more x's than the lowest number of x's you've got. Okay, so you can take one x out of here, you can take one out of there, and you can take one out of there, but you cannot take, if you decided that you wanted to try and take an x squared, you don't have 2 x's here to take. So that's not going to work. The greatest number of x's that you can take is a single x. So out of the numbers, we can take a negative 3 and a max of 1x. So negative 3x cubed divided by negative 3x. Basically, factoring is a way of dividing. Okay, factoring is a way of dividing. So we're going to divide negative 3 by negative 3. And if we lose this x down here, we're taking one of those with it, leaving an x squared. Okay, now we've got 15x squared, the next term in line, divided by the negative 3x out front. 15 positive divided by negative 3 is a negative 5. And when we lose the x in the bottom, we're going to take one on the top with it. And then the last term is a negative 36x divided by that negative 3x out front. So negative 36 divided by negative 3 is a positive 12, and both x's divide away. Okay, but we're still not done. We still have an x squared. Anytime you see an x squared, just because we factored out the GCF does not mean that we're done. If we see an x squared here, we are going to attempt to factor it. Maybe it won't work, but you need to try. Okay, so we've got a second sign there that's a positive. That means that both the signs are the same and they're both negative. Okay, remember, the second sign is what determines what goes inside these factors. Our second sign is a positive, so both signs in the factors are whatever the first one is, and it's a minus. So x minus and x minus. And one thing that you need not forget, and at least a third of you will, is to carry down the negative 3x that you've already taken out as the GCF. Now, we need two numbers that multiply to be 12, and that when we combine them, we'll get a negative 5. So we need all the factors of 12. Let's clean this up a little bit so it doesn't confuse things here. Okay. So the factors of 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And then we would just be repeating 4 times 3, 6 times 2, etc. Well, there's no way that we can combine 1 and 12 to get a negative 5. That ain't going to work. Now let's look at 2 and 6. 6 minus 2 would give us a 4, and 2 minus 6 would give us a negative 4, but we need a negative 5. So that pair doesn't work. And 4 minus 3 is 1, and 3 minus 4 is negative 1. So that pair isn't going to work either. Okay? So for our intents and purposes, there is no further factoring that can be done with this. So that means that for right now we will be able to factor that later on. But for the skills we've got in our factoring toolbox, that's as far as we can go with that one. We took out a GCF, we attempted to factor what was left over, and found that it didn't work. Okay? So right now, that's where we stop with that. Okay, moving on. Hopefully you guys are taking really good notes. All right, so in example 3, I'm going to teach you how to do a method called slide and divide. It's probably the simplest way to factor when your leading coefficient is not a 1. So like right back here, okay? The leading coefficients on these, and I'm going to be writing in a bright yellow, the leading coefficients on this, that's a 1, okay? Here, we've got a 1, okay? So the leading coefficient is the number stuck to the highest degree. So the leading coefficients there are 1s. Makes it easier to, definitely easier to factor. But when we get into something like example 3, we have 5x minus 2 plus 12x squared. First of all, that is in the wrong order, okay? You lead with the highest power and then go in descending order. So we need to rewrite that so it's in the proper order. Starting with the x squared, then going down in degree. Positive 5x minus 2. So this is what we're factoring. Okay, notice our leading coefficient is not a 1 now, it's a 12. And we want to make it easier to factor that. Okay, so what we're going to do is a method called slide and divide. Pay attention. Okay, so the first thing we're going to do is divide away whatever the number is stuck to the x squared. Divide it by itself, and then we'll end up with just an x squared when 12 divides by 12, okay? So we're going to divide away that 12, but we're going to multiply it by the last number, the constant, okay? And this is the way it will work with every single slide and divide problem. So for right now, what we are temporarily factoring is 12 divided by 12 gives us the x squared plus 5x, and the product of negative 2 and 12 is negative 24. So what we are temporarily factoring is x squared plus 5x minus 24. So we're going to go to the side, and take all the factors of 24. 1 in 24, 2 times 12, 3 times 8, and 4 times 6. And one of those combinations is also going to combine to give us a positive 5. So let's check in with our sign thing first. The second sign is a minus. So that tells me that in each one of these factors, I'm going to get an x plus and an x minus. Remember, the signs are different if the second sign is a minus. Okay, so we need two numbers that we can add or subtract together to give us a positive 5. Well, 8 and 3, when 8 is positive and 3 is negative, 8 minus 3 is positive 5. So 8 is positive and 3 is negative. Okay, so far we've gotten our temporary polynomial factored. Now what we need to do is reintroduce the 12. So we will divide each one of the numbers in our factor by a 12. Okay? And reduce the fraction if you can. Every time, reduce the fraction if you can. So 8 over 12 reduces to 4 over 6, which reduces to 2 over 3. Okay? And 3 over 12 reduces to 1 over 4. Now, I would say you're done, except for the fact that you are not going to be allowed ever to leave fractions in factors. So we need to deal with the 2/3 and the 1/4. Very, very easy fix. Once we get our fraction down to its lowest term and we still have a denominator, we're going to take that denominator and just stick it in front of the x. We're going to take this denominator and just stick it in front of the x. So our factors are 3x plus 2 and 4x minus 1. Okay? We will do definitely a couple more slides and divides, okay? So, let's see. We have in example 4, okay, again, slide and divide because the leading coefficient is not a 1. Okay, we'll start with the GCF. 3 doesn't come out of anything there. And because we don't have an x here, we can't factor out an x either. So we're stuck with what we got. So slide and divide. The first thing that you will do in slide and divide is divide away the leading coefficient by itself. So once you divide away the 3 out front, you're going to multiply it here at the end. So 3 divided by 3 will give us the polynomial that begins with a 1, and this is our temporary polynomial. X squared plus 19x minus 14 times 3 is 42. Okay? So what we're factoring is this temporary polynomial, factors of 42. 1 in 42, I better change colors, that doesn't look like it's dark enough. 1 and 42, 2 and 21, obviously 3 and 14. And actually, let's do our sign thing right now. The second sign is a minus. So I know that I'm going to have an x plus and an x minus as our signs and our factors. And I need a combination of these factors of 42 that when I put one of them as a positive and one as a negative, I get 19. And I already have that. over here in 2 and 21. So if 21 is positive and 2 is negative, 21 minus 2 is positive 19. Okay, and I already know that when I multiply them, I get 42 because that's a factor. All right, so I have temporarily factored my polynomial with a leading coefficient of 1. Now I need to reintroduce the 3 that I took out initially. So that 3, let me change colors here. I'm going to do red. Okay, I'm going to reintroduce the 3 by dividing it into the 21 and into the 2. Okay, so now we're at the point where we're going to reduce the fractions as far down as they can go. Well, 21 divided by 3 is 7. No fraction anymore. So we don't have to worry about a denominator. But x minus 2/3, that cannot be simplified or reduced any more than it already is. And because we don't want that 3 in the denominator, we're going to take the 3 and just stick it in front of the x. And we are done. Okay? Another example. First of all, I'm going to teach you some more, or not teach you, we're going to go through some more slide and divide in example 5b, okay? And then we're going to learn another pattern. Okay, actually we're doing, instead of example 5b, because the number gets really, really big, we're going to keep it a little simpler, just in order to become more familiar with the slide and divide, okay? So the numbers don't have to be huge. We just need to make sure that we can follow the method, okay? So our leading coefficient is not a 1. That means that we are going to divide away the 2 and multiply it at the end, okay? And then we'll look at our signs. The second sign is a minus. So that tells us that the factors have an x plus and an x minus. Okay, now we're going to take all of the factors. Hold on one second. All of the factors of that product, which is 26. Okay, so 1 and 26 and 2 and 13. And that's all we've got, okay? So the combination that gives us an 11 negative would be when 13 is negative and 2 is positive. 2 minus 13 is negative 11, and when you multiply them together, you get negative 26, okay? So that is our temporary, or I should say our temporary was our x squared minus 11x minus 26. Sorry, guys, left that out. Hopefully you picked up on that. Okay, so the 26, we found the factors, and now we're done with the temporary polynomial. Now we will reintroduce the 2 by division, okay? Reducing whatever factors or whatever fractions we can. 2 divided by 2 is a 1, and the 13 does not divide by 2 evenly, so we'll just stick it in front of the x, and now we are done. Okay, another example down here, 3x squared. So our 3 is what gives us our problem. So that is what we're going to divide away here and multiply at the end, giving us x squared minus 13x minus 30 to, that's our temporary polynomial there. And we need factors of 30. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And then we start repeating, not necessary. Okay? So now that we've got the factors, I'm going to check my signs rule. The second sign is a minus. So I've got an x plus and an x minus. So I need two combinations of these factors, or these factors over here, that when I add them together, I'll get a negative 13. Well, that is found in 2 and 15, as long as 15 is negative and 2 is positive. 2 minus 15 is negative 13, and when I multiply those together, I get a negative 30. So I have temporarily factored, but now I need to reintroduce the 3 that I took away initially. So I'm going to divide it by each one of the numbers here. 2 over 3 does not simplify as a fraction. So the 3 will get stuck to the x. And 15 divided by 3 does reduce to 5. So now I'm done. Okay, the only other thing that we are going to worry about here is recognizing perfect square trinomials. So we start off with example 5a. We have x squared, 1x squared, plus 10x, plus 25. Okay? Now we could factor this to say two numbers that multiply to be 25 have to add to be 10, and both my signs are the same, and they're both positive, okay? That will still work. But there's also a method to recognize perfect square trinomials, and that's the goal, okay? Look at the first number and the last number. And if both of those are perfect squares, we're going to test it for a perfect square trinomial. Take the square root of each one of these numbers. The square root of 1 will be a 1. The square root of 25 gives us a 5. Okay, so we've got a 1 and a 5. Multiply those two numbers together, okay, which will give you a 5. And if you can double that number and get what your middle number is, this is a perfect square trinomial. Okay, so 5 times 2 is 10. That means that this is a perfect square trinomial. Okay, and the factors are going to be exactly the same. We're going to have two of them. The square root of x squared is x. The square root of 25 is 5. And we'll bring our first sign down with us. And now we have factored. Okay, let's do another one. And the really nice thing when you recognize the pattern for a perfect square trinomial is that you can disregard that middle term because it takes care of itself, okay? So we're going to look at the first number and the last number. 4 is a perfect square, and the square root of 4 is 2. 49 is also a perfect square, and the square root of 49 is 7. Okay, so that part is done. So now we're going to multiply those two numbers together and get that product. If we can multiply that by 2, every time it's 2, and get the middle number, then this is a perfect square trinomial, okay? And the perfect square trinomial would be a factor multiplied by itself twice. So the square root of 4 is 2. The square root of x squared is x. The square root of 49 is 7. And we bring down whatever that first sign is. And you are finished. Okay? Okay, next type of a problem has a mix of variables, x's and y's. So we're going to start with a GCF because I recognize 7 goes into 21 and 28. So we will factor out a 7, x squared minus 3xy minus 4y squared. Okay. Now I'm going to use my my factoring a perfect square trinomial skills to see if this is a perfect square trinomial. I've got a 1 and a 4. Okay, so the square root of 1 is 1. The square root of 4 is 2, and I'm going to multiply those together and then double that. Well, this is not a perfect square trinomial because 2 times 2 is not 3. So don't assume it will always work because it doesn't always work, okay? That was a really good example to show that not every single trinomial that begins and ends with perfect squares is actually a perfect square trinomial, okay? This is one of those instances. So we need to get 2 factors here. Okay, we need 2 factors here. Our second sign is a minus. So we've got an x plus and an x minus. Okay, so we're going to do exactly what we were doing before. We are going to look for factors of 4. So we have 1 and 4 and 2 and 2. Well, the only factors that will combine to give us a -3 are the 1 and the 4, when the 4 is negative and the 1 is positive. The last thing we need to pay very close attention to is this y squared at the end, okay? So the square root of y squared is y. So notice at the beginning, we have x squared. The square root of x squared is x. So 1 goes there and 1 goes there. It's the same idea with the y squared. The perfect square of y squared is y. So 1 goes here and 1 goes there. And now we're finally through.